Let's take a look at this question. I'm just going to make the diagram a little bit bigger. So we have that they're integer side lengths, whole numbers, divided into 4 smaller rectangles as shown, and the perimeters of the largest rectangle, that's going to be this one, and smallest, this one, are 28. I'm just going to put 28 in here. It's not an area, I mean the perimeter, and 12. And then I'm going to label it A, B, C, and D. So I can see straight away from this that it must be 2a plus 2c is 28, and therefore a plus c is equal to 14. And meanwhile, 2b plus 2d is 12, so b plus d is equal to 6. And from that, we see that the semi-perimeter, if I add them all up, a plus b plus c plus d must equal 20. And remember, when I find the area of the original rectangle, it's going to be a plus b multiplied by c plus d. So basically, I need two numbers that are going to add to give 20, but multiply to give something here. And so you could maybe try some of them out. 10 and 10 would give 100. That could work, but although you wouldn't end up with a well, I mean, it'd be a square, which is an example of a rectangle. 11 and 9, but that's not on the list. So maybe 8 and 12, that adds to give 20 and multiplies to give 96. And that is going to be the answer. That is enough for this intermediate maths challenge. Like technically you should show that none of the others can work, but it's enough here to to be sure. I feel like it's also, it would be if you just kept trying some other ones, so 7 times 13, which is 91, like you can sort of see, surely if they have to be integers, then it's enough to just like try the values out. Arguably, you should prove it algebraically. So that is a really good approach for this question. I'm actually going to show you another way to do it, and this is the way I did it. And I'm not saying it is good by any means, but I'm just, sometimes you don't. It's good to discuss other sorts of answers. So the way I did it was I wrote that A was 14 minus C, and that means that the maximum value of C is going to be 13, because otherwise A would be 0 or negative. And then we also get that B is equal to 6 minus D, and that means the maximum value of D is going to equal 5. And hence the maximum value of C plus D is going to equal 18. It can't be more than that. Now, if I want to find the area, which is A plus B times C plus D, then I could substitute in for A and for B. So I've got it in terms of C and D. And that will actually give me 20 minus C plus D if I factorize it times C plus D. So I've got the area, I know the maximum value is 18, and so I can just sort of try some out now. I can do 20 minus 18 times 18, which would give 36. That's not on the answer list. Then I could try 17. Okay, I'm just going down one every time. I don't know what C and D are, but I know that, the maximum is 18, so I've tried that. Now I'm trying 17. So 3 times 17 is 51. That's not on there. And I just keep going. 4 times 16 is 64. You can see it's getting larger and we're like approaching one of the answers. That's going to be 75. 6 times 14 is 84. Okay, you can maybe skip some if you see it's not going up like that quickly. That one's 91. And finally, this one would be 96. And we could be sure at that point we've got the answer. Could maybe just check that you don't get 98 by trying 11. That would be 99. And then we'd get 100. I suppose, how do you know it's not going to sort of come back down? Well, there might be a minimum value of C and D as well. I've not really thought about that. Okay, actually, this would just be the rectangle, but go in the opposite way. So we're just going to repeat values now. So you can be, I feel like I can be pretty sure at that point that, that is fine, that none of the other solutions work. I mean, the main thing is that it is there, so it's okay. But if we didn't have a multiple choice answer, then at least I could list all the possible areas like I have here.